Hi all, in this video we're going to start actually applying the transformations to the graphs of sine and cosine. So we'll start off not too messy, and then in later videos we'll work up to messier stuff. Okay, so first one I have is starting with a cosine wave. Cosine, remember this is your first task, is to make sure you have these memorized. So cosine starts at 0, 1, and then has a period of 2 pi, and the maximums are at 1 and the minimums are -1. Okay, so this is the graph I'm starting with. And the transformations I see are vertical stretch. If you multiply the entire cosine function by 2, that's going to be vertical stretch by 2. And what that directly affects is the amplitude. So the amplitude of this new one is going to be 2. Remember, amplitude doesn't mean the total height. The total height of the original sine wave is 2. Amplitude is how far you go up and down from the middle, the equilibrium. So here our equilibrium is the x-axis. We go up and down 1 to hit our maximums and minimums. We're doubling that, so this thing is now going to be twice as tall. Okay, so this is what I'm picturing. We're then going to shift it down 3, which means our equilibrium will no longer be the x-axis. It will be at y equals -3. So we're going to start at y equals -3, and we're going to go up and down 2 to get the top and bottom. So I think I'll move my x-axis up here a ways. Okay, so x, y, and here you can see I'm already breaking away from some of that unit circle variable naming. So I'm saying cosine is a function on its own. Yes, if I'm thinking about what it means, I'm thinking the unit circle, but I don't have to call the input variable t and the output variable x. I can call them whatever I want. So here, what's going on my x-axis is arc lengths, and what's going on my y-axis would be the x values from the unit circle. But we just want to focus on cosine as its own function. Okay, so we're taking this stretched out graph that goes up and down 2, and we're shifting it down 3. So let's say that's our -3. Okay, so -3 equilibrium, you don't have to do this, but I tend to just dot in really lightly, or however you want to do it. I don't use dashes because dashes are supposed to show asymptotic behavior, but just some sort of visual for myself where I say, okay, the middle of the graph is vertical center is at -3, amplitude is 2, which means the top of the cosine wave will end up at y equals -1, and the bottom will end up 2 down at y equals -5. So figure out where the middle is and then go up and down according to your amplitude. Okay, so let's see. We don't have any horizontal anything, stretch, flip, shift, none of that. So one thing that it's good to start trying to pay attention to is, okay, well, if I stretch this out and then shift it down, I'm still expecting that my y-intercept is a maximum. So here, 0, 1, we can follow it really carefully just to make sure we're right. But I would say I'm predicting that it'll land right here. It'll be still at that maximum y value. So to follow it, we say, okay, 0, 1. If we do vertical stretch by 2, it ends up 0, 2. If we then shift down 3, it ends up 0, -1. So right where I was hoping. We also, so again, we haven't stretched or compressed or shifted, so we know that the period is still 2 pi. If you want to think about the b value in this, it's 1, no stretch or compression, so the period is still going to be 2 pi. There is no phase shift, no horizontal shift, so no phase shift. Okay, so let's see. If the period is 2 pi, let's say this is pi and 2 pi, then we know that we're going to do a full picture. So we're going to start heading, this is the maximum. We're going to have to first head down, just like this, down, and then back up. And we should get back to the maximum again right at the other end of our period. From there, you can just start breaking it down. If you have a period of 2 pi and you have maximums on either end, you should have a minimum always right smack in the middle of 2 maximums. And then in between any max min or min max, you should hit equilibrium, which is at 3. So in this case, pi over 2, negative 3, and then 3 pi over 2, negative 3. Okay, so here is one period of my new cosine wave. So notice, here's a full period. In half a period, you went from a max to a min. In a quarter of a period, you went from max to equilibrium. That quarter of a period increment is really nice. So if you know your period is 2 pi and you divide it by 4 and get pi over 2, that's really nice tick mark labeling to use. So here's my pi over 2, a quarter of the period, I went from max to equilibrium. Here's another quarter, equilibrium to min. Here's another quarter, min to equilibrium, and then another one, equilibrium to max. So every quarter of a period, you're going to jump from one of those key nice points to another one. And then we should just have the exact same sort of behavior on the other side. We should head in pi over 2 units down to equilibrium, in another pi over 2 down to the minimum, in another pi over 2 we'll be back up to equilibrium, and then in our last quarter of a period, so this is a full period, we get back up to our max. Okay, so there's a picture of that cosine wave. I also have a sine wave for us to look at in this video. So this sine wave, okay, so let's see, let me not get too far ahead of myself. I'm picturing sine right off the bat. This is 2 pi and pi. And again, 1 and negative 1. Okay, so the transformations I see. So here's my sine function. I have a flip. It's out in front of the sine function, so it's flipping my y values, which means over the x-axis. So now I'm picturing this. I also have horizontal compression. So I am dividing all of my x's by 3. So this whole thing, it was going out to pi and then 2 pi to hit equilibrium again. It'll now only go to pi over 3 and 2 pi over 3 to hit equilibrium again. So scrunched in, it's going to squash all those x coordinates. I don't see any vertical stretch or shift, so amplitude is going to be 1. It's going to continue to be this up and down 1 unit from the middle, the vertical center. And since there is no plus on here, it's a plus 0, that means the center, the equilibrium, is also 0. So my y's are going to do this exact same thing, go from negative 1 to 1 to negative 1 to 1, back and forth and back and forth. My period did get messed with this time. My period, remember to find it, you take 2 pi and you divide it by 3. So again, you can just remember that formula, but I hope it makes sense, because if I take something that has a period of 2 pi and I compress horizontally by 1/3, 1/3 of 2 pi is 2 pi over 3. Okay, and then what am I missing? Phase shift. I don't see any phase shift here. Nothing added to your x's or subtracted from your x's, so that should be good. So let's put our x-axis right smack in the middle, or at least close to it. I'm a little crooked. Okay, so x and y. And again, x's are actually representing arc lengths. Here, y's really are y's on the unit circle, so that one's a little easier, but x means arc length on the unit circle. Okay, so I know the top, I'm just going to change my scale. I'm going to say this is 1 and negative 1, so it's not quite so squished. So the graph should go up to 1 and down to negative 1. Okay, and then We know it's upside down, so here we can snag a point to follow just to be really careful. 0, 0. So the flip upside down won't move it, and when I squash everything towards the y-axis, it still won't move it. So in this case, with no horizontal shift, the equilibriums continue to be equilibriums, so 0, 0 is still going to be our equilibrium. And then from my thinking here, so I flipped it upside down and then I squash it, I know from this point that I just followed to the same exact spot, I should first head down to a minimum. So from here I'm going to head down, but before I get too far I want to think about size of my tick marks. So here I had a period of 2 pi over 3, and remember, nice tick marks are if you divide that by 4, quarter the way around the circle. So when I do that, I can cancel out a 2 and I get a pi over 6. So I'm going to say this is a pi over 6, and then 2 pi over 6's would be a pi over 3, and 3 pi over 6's would be a pi over 2, and then out here would be my full period. Since I'm a little crooked, it didn't quite fit. That would be my 2 pi over 3. So that's 4 pi over 6's, which is a 2 pi over 3. And then we'll do similarly here. There's a negative pi over 6, pi over 3, pi over 2, and 2 pi over 3. Okay, so we start at 0, 0, and we head down, and in a quarter of our period, so pi over 6, we should hit the bottom. And then we should head back up to equilibrium within quarter of our period, and then up to maximum, and then back down to equilibrium. If you don't like the quarter of your period thing, you can also start by saying, okay, if I go a full period starting at equilibrium, I should end at equilibrium, but be really careful with that because equilibrium you hit more than once in a period. So if you're starting and ending at a period, you should also have one, at an equilibrium, you should also have one right in the middle of your period. And then between those, you'll have minimums and maximums, and you'll need to pay attention to that flip to decide which one comes first. And then it's just going to mirror this on the other side. So there's 2 full periods of my sine wave. And in general, I expect you to be able to show me 2 full periods. On tests, I usually specify if I only feel like I need to see one, I'll say. But be ready to show me 2 if asked. And if you don't have a nice, clearly labeled grid, I want to make sure that I can tell exactly where one of your maximums and one of your minimums and one of these equilibrium points are. So be prepared to label those if I can't tell from the scale you start with. All right, thanks for watching.